question says determine the period of each function. We're going to again add the fact that we're going to graph each of these as well. Notice in each of these they have a horizontal stretch or compression. That 6 in A is inside the function. Okay, so you're going to multiply your x values by 1/6. Your y values aren't going to change. So the biggest thing that an x value compression is going to do, can you see that that's going to change your period? On our normal graph, our period was 2 pi. But now we're going to squish it by 1/6. And so what we can do when graphing this is normally we would draw 2 pi and draw our axis family divided into 4 equal sections. But now we multiply our period by 1/6. I'm going to just write 2 pi over 6. You could reduce that to pi over 3, right? Then next you would write pi because it was half of 2 pi. What's half of 2 pi over 6? Pi over 6. What's half of pi over 6? Pi over 12. And once you get the first one, since they're all equally spaced, you can count 1 pi over 12, 2 pi over 12, 3 pi over 12, which you could reduce to pi over 4 if you wanted to. But again, you don't have to reduce things, so we could leave it like this. Now, a maximum is 1 and a minimum is -1 for a sine or cos graph. This is a cos graph. Where does a cos graph start? At a maximum. So when I'm graphing this one, I'm going to start at my maximum, then to center line, then to minimum, then to center line, back to maximum. If I wanted to draw my center line on there, it stays at y equals 0. So my period is pi over 3. Why would I lose an E9 error on this one? No arrowheads. There we go. Whew. All right. Part B. Tan of 2 pi over 3. What's happening here? We would multiply x by 3 over 2. Multiply by the reciprocal. So if you think about your tan graphs, your tan graph had an asymptote at pi over 2, another one at 3 pi over 2. I'll include the one at negative pi over 2. That's where it was originally. But what's going to happen when I multiply? So it was pi over 2. If I multiply it by 3 over 2, can you see that you will get 3 pi over 4? And this one was at 5 pi over 2? This one was at 3 pi over 2. If I multiply that by 3 over 2, I'm going to get 9 pi over 4. And here I'll even show the work. 3 over 2 times by a negative pi over 2. You're going to get negative 3 pi over 4. Tan graph keeps the same shape as it did before. And it would keep going. The period of your tan graph is the distance from one asymptote to the other asymptote. So how far is it from here to here? From negative 3 pi over 4 to 3 pi over 4? 6 pi over 4. which you could reduce to just be 3 pi over 2. That also should make sense because normally you went from negative pi over 2 to pi over 2. Your normal period of period of tan is pi. So if you multiplied by 3 over 2, your new period would be 3 over 2 times pi, or 3 pi over 2. And finally, the last question was sine of x over 7. This is the same as y equals sine of 1/7 x. Does it make sense that you are multiplying your x by 7? Normal sine graph, you'd mark 2 pi and divide it into 4 equal sections. But if you're stretching it horizontally by 7, can you see that your 2 pi would change to 14 pi? Half of 14 pi would be 7 pi. Half of 7 pi would be 7 pi over 2. And then if you count 1 7 pi over 2, 2 7 pi over 2s, 3 7 pi over 2s would be 21 pi over 2 for your third one. The maximum for sine is 1, minimum is -1. A sine graph starts on your sinusoidal axis, going up. So I'm starting here, going up, maximum, back to center line, minimum, back to center line. Perfect. And we've drawn our graph. What's our period? The period is 14 pi. So because of this, at the bottom of your page, they've got this bubble that says period of a trig function, and they've got formulas. And I've rewritten them underneath. They've got a formula for your period, which says your period is always 2 pi, because that's what you started with for sine and cos. Your period starts at 2 pi. And then whatever your b value is, because you have to multiply by the reciprocal, your period is just going to be 2 pi divided by your b value.
What is b?
B is whatever the horizontal stretch or compression is. So if you have y equals sine bx or y equals cos bx. And the reason we use b is because when we combine everything together with all of our transformations, we just keep going up by letters. And so A is for vertical stretches and compressions. It also is what amplitude starts with. And B relates to the period, so it's perfect. Yeah, I should stop. And then C will be a shift left and right. Shift, yeah. And then your D value shifts things up, which changes your sinusoidal axis. So it's, yeah, I've never tried that before, but that worked out most excellently. With your tan graph, since your original period is pi, then your new period will be pi over b. And for both of these formulas, we've got our period formula for sine and cos and our period formula for tan. You could rearrange those to get a b value formula, because we're going to have to work backwards as well. We're going to have a graph where you know the period is 3 pi. You're going to have to write what the equation is. So you'll have to figure out what your b value is. Okay, questions for number 2 are 3, C, and D.